In this section we cover a class of compounds called hydrates. Hydrates occur in nature when ionic compounds form. Basically, most ionic compounds form when the ions are dissolved in water and they're floating around in the water and the water starts to evaporate. And the ions, which have positive and negative charges, get closer and closer together as the water evaporates. Now eventually there's not a lot of water anymore, and the forces of attraction between those ions are strong enough that they start setting up and forming crystals. The little bit of water that's remaining that hasn't evaporated yet gets trapped inside. It's very predictable for each compound to know how many water molecules are trapped within the crystal in relation to how many positive ions you have and how many negative ions you have. So in nature, ionic compounds form typically as hydrates, and they always have a predictable amount of water trapped in them. For example, CuSO4, when that comes together to form a compound, it traps 5 molecules of water for each and every ion of copper and each and every ion of sulfate. Now, to name this compound, we use the name of the salt that we've already learned, but then we have to add on one more piece telling us that this has water trapped in it. So for the first part of this, I look at copper and sulfate, and since copper needs a Roman numeral, I look at the charge of sulfate. Charge of sulfate is 2 minus, so here the charge of copper is 2 plus. This portion of the compound is copper 2 sulfate. The last part of this is to tell how many water molecules are trapped within the crystal. For example, 5 is penta, so this would be pentahydrate, or 5 water molecules. So copper 2 sulfate pentahydrate would be the name. In the next example, I have the salt MgSO4. That's magnesium sulfate. In this case, I have 7 molecules of water that's trapped within this crystal. So the name of it, magnesium sulfate heptahydrate. That tells us 7 molecules of water for every ion of magnesium and every ion of sulfate. Now, the water molecules are technically not bonded to this crystal, but they're attracted to the magnesium ions and the sulfate ions, so they became trapped within the crystal. We can remove the water. If we strongly heat this salt, the water could be freed from it. In that case, we'd be left with the compound magnesium sulfate. We would call it an anhydrous salt, an meaning not, hydrate meaning with water. So anhydrous salt means the salt without the water. Now the reason why we don't just say it's a salt, we say it's an anhydrous salt, is because in nature this salt forms as a hydrate. So it's magnesium sulfate heptahydrate. When we heat it and we get rid of the water, we're left with the salt but without the water. So this is my hydrate, and after heating I get an anhydrous salt called magnesium sulfate.